Hey guys, we're going to do a quick walkthrough of the Unit 6 Lesson 1 classwork in case you weren't here and you need to double check your answers. So today's standard is 8.EEA1, which is to know and apply the properties of integer exponents to generate equivalent numerical expressions. And the objective is I can explain and use a rule for multiplying powers of 10. And so for the warm-up, I have you have this right here, right? And you would solve for x using substitution. And so you can see I substituted the variable y for y equals x minus 4. And then I did the distributive property here, right? I combine like terms next. So negative 8 minus 18 is negative 26. Then I subtracted the x over. So the next step was I subtracted x over, and then 2x minus x is x, and then I add over the 26. 9 minus 26, 9 plus 26 is 17, which equals x. Now for the next one, we have complete a table based on the given linear equation. Y equals negative 2x plus 2, and y equals x minus 3. So you can see here, I have solved it for you, and here I've chosen my inputs. For you guys probably seeing it blank, and over here, I chose the inputs 8, 2, 10, and 7. Over here, it's negative 3, negative 2, 5, and 2. And so you're taking the input, you're plugging into your equation, and then you're getting the answer for your output, which is y. So negative 3 times negative 2 is 6. 6 plus 2 is 8. Negative 2 times 4. 4 plus 2 is 6. 5 times negative 2 is negative 10. Negative 2 plus 2 is negative 8. 2 times negative 2 is positive 4. 4 plus 2 is 6. No, negative 2. Because negative 2 times 2 is negative 4. Negative 4 plus 2 is negative 2. And over here, I chose 8, 2, 10, and 7 for my inputs. So 3 times 8 minus 3, because this is the equation, would be 21. Plug in 2. 3 times 2 minus 3 would be 3. Plug in 10. 10 times 3 is 30. 30 minus 3 is 27. Plug in 3. 3 times 7 is 21. 21 minus 3 is 18. Okay. Make sure you're using the video to check your answer and not just copying. Okay. Try your best first and then check the video. So now today's lesson is going to be about exponents. In general, exponents make it easy to show repeated multiplication. For example, 2 to the 6th is 2 times 2 times 2 times 2 times 2. One advantage to writing 2 to the 6th is that we can see right away that this is 2 to the 6th power. When this is written out using multiplication, 2 times 2 times 2 times 2, we need to count the number of factors. Imagine writing 2 to the 100th using multiplication, right? So we use an exponent or a power to rewrite repeated multiplication so it's smaller, easier to see. Okay. So here's the answers for the first part. So yeah, 7 times 7 times 7 times 7. That's going to be 7 to the 5th, right? And if you're wondering how to get to that 5, you're going to do control dots, right, to make an exponent. So control dot will make the number go up, and that's called a superscript. You can also go to Format, Text, and click on Superscript again, and it will make the superscript. Once you're in superscript mode, you have to get out of superscript mode by clicking it again, okay? So I click it once, and it gets me out of superscript mode. I click it, go text, superscript, and I'm back in superscript mode. So you have to click that, okay? So now 4 fifths times 4 fifths times 4 fifths times 4 fifths. There's 4 fifths multiplying each other, so it'll be 4 fifths to the 4th. 9.3 times 9.3 times 9.3 times 9.3. There's 8 of those, so it'd be 9.3 to the 8th. And then 2 to the 6 is 2 times 2 times 2 times 2. And then 3 to 3 is 3 times 3 times 3. 4 to the 3rd is 4 times 4 times 4. 6 squared is 6 times 6. So the exponent tells you how many times you're going to write that multiplying each other. 1/2 is 1/2 times 1/2, and so on. And then 1/3 is 1/3 times 1/3. And so that's the use. This is with the exponent, and this is without the exponent. They mean the same thing. Okay. So now going to the next one, multiplying powers of 10. So for you should fill this out and try to figure out what the pattern is, right? What's the pattern, right? For you guys, like this, for you guys, this should be empty. This should be empty, right? And so you're filling it out. Right here, this should be empty. You're filling that out. This should be empty. So you're filling out the chart. You're filling out the chart. And then you're going to complete the table to explore patterns in the exponents with multiplying powers of 10. You may skip a single box in table, but if you do, be prepared to explain why you skipped it. So notice that the first one is the expression with the exponent. The second is both exponents expanded. So 10 squared is 2 tens. 10 cubed is 3 tens, 1, 2, 3. And then the last column is put back together as one exponent. So you see there's 1, 2, 3, 4, 5. So there's 10 to the 5th. So you're filling out those tables, right? And then for 2A, you're going to try to find if you have a pattern. Like, is there a pattern from this column to this column? Like, what's the pattern? Don't look at the last page. The last page tells you the answer. Just try to figure out the pattern and check your answer for the last page. Okay? I'll pause the video here. Okay. So now going to the next one, you can see here, the pattern is when multiplying powers, you add the exponents and rewrite it with the common base. And so, for example, if you have 10 squared times 10 to the 3rd, 2 plus 3 is the same as 10 to the 5th. Okay. So you have 10 to the n times 10 to the m equals 10 to the n plus m. Okay. Now we want to write each expression with a single exponent. So you're going to do 3 times, so 10 to the 3rd times 10 to the 9. So when you're multiplying them, when you multiply in powers, you add the exponents, we write it with the common base. So 10 to the 3rd times 10 to the 9. So you add 3 plus 9 is 12. And then, so 10 to the 12th. So this is the same thing as 10 to the 12th. 10 to the 1 power times 10 to the 4th is the same thing as 10 to the 5th. 10 to the 10 times 10 to the 7th, the same thing as 10 to the 17th. 10 to the 3rd times 10 to the 3rd, same thing as 10 to the 6th. 10 to the 5th times 10 to the 12th, same thing as 10 to the 17th. You're adding the exponents, right? Each time you're adding the exponents if they have the same base. So now over here, 10 to the 6th times 10 to the 6th times 10 to the 6th is 10 to the 18th. Okay. So make sure that you read the summary, that you annotate it, that you make any notes. Send me any messages if you don't understand anything. But make sure you're checking the answers with the video and not just copying them. I'll see you next time.